Some computations are very expensive to do. If you store your information as base units in your database, you may find yourself redoing the same computations, manipulations, or transformations over and over. In big data systems, these kinds of repeated computations can lead to very poor performance. What kind of transformations are usually applied to data? The list is long, however, they usually fall into one of those three categories: mathematical operations, fan-out operations, and roll-up operations. We will group those under a new pattern, which we will call the computed pattern. The mathematical operations are easy to identify. These are the ones where we compute a sum or an average, find a median, etc. These are often associated with calling a built-in function in the server. Why does it matter that we want to apply a pattern here? Let's say we have a write operation that comes in. This piece of data is added as a document to a given collection. Another part of the application reads this collection and does, let's say, a sum on the numbers. If we are doing 1,000 times more reads than writes, the sum operation we do with those reads is identical and very often does the exact same calculation for each of those read operations. We can save ourselves from all those identical operations by calculating the result when we get a new piece of data. Once we have a new piece of data, we read the other element for the sum and store the result in another collection, with documents more appropriate to keep the sum for that element. This results in much fewer computation in the system, and we also reduce the amount of data being read. See here. Each sum reads all those documents. Since we don't have to do the computation at read time, we also save on those read operations too. In this example, that will be 1,000 fewer computation and 1,000 fewer reads. A good example of this will be keeping track of ticket sales and then reporting the sale numbers, let's say for a specific movie, on a movie website. There are likely fewer screenings happening per hour, which will be our writes, than page views for the given movie where we want to display the sums. So instead of summing those screenings document to display the total viewer and sales every time I access the movie, we are better off keeping the information in the document and updating it every time we get a new screening document. We don't have to keep the screenings once the calculation is done. However, they allow us to regenerate the sums if needed, or give us the ability to do more analytics. Fan-out operations. First, what does fan-out mean? It means to do many tasks to represent one logical task. There are two basic schemes. Either you fan out on reads, which means in order to return the appropriate data, the query must fetch data from different locations, or you fan out on writes, which means every logical write operation translates into several writes to different documents. In doing so, the read does not have to fan out anymore, as the data is pre-organized at write time. If you don't pay attention to this pattern, you are likely doing fan out on reads. Why would you use fan out on writes? If the system has plenty of time when the information arrives compared to the acceptable latency of returning data on a read operation, then preparing the data at write time makes a lot of sense. Note that if you are doing more writes than reads, so the system becomes bound by writes, this may not be a good pattern to apply. A good example for this pattern will be a social networking system for sharing photos. The system may copy the new photo on each follower's own page as it gets the new photo. This way, when a user loads its own page, the system does not have to spend resources assembling all the information from all the people this user follows. Everything needed for the user's own page would be available via a single document, which leads to a much better experience with the site. Roll-up operations. We use this terminology in opposition to drill-down operation. In a roll-up operation, we merge data together. For example, grouping categories together in a parent category will be a rolled-up. Grouping time-based data from small intervals to large ones will be another good example of a roll-up. This type of roll-up is often seen in reporting for hourly, daily, monthly, or yearly summaries. Any operation that wants to see data at a high level is basically looking at rolling up data. Mathematical computations are roll-ups. However, roll-ups are more generic. You can often think of roll-up data as running a group operation. So similarly to mathematical computation, doing those roll-ups at right time may make more sense than having or read operation pay the cost of processing the transformations. Let's look at a concrete example. An inventory has different wine types. The inventory changes once in a while, however not frequently. What is more frequent is looking at the wine organized by various categories. For example, I may want to see the count of wine types per country of origin or per type, so I can buy what is missing in my inventory to cover all my customer needs. If I'm looking more often at the information on the right, the non-aggregated data, than the changes that are happening on my collection on the left, it makes more sense to generate this data and cache it in the appropriate documents. When should you apply the computed pattern? If you see you are using a lot of CPU, this may be a sign that you're doing much more than transferring data from and to the disk. Keep in mind that some tasks like compressing and decompressing data between the disk and the cache requires a lot of CPU too. Secondly, if you have long read operation that depends on complex aggregation queries, you might want to make them run faster. Time to formalize or computed pattern. The problem the computed pattern addresses is avoid redoing the same computation over and over, especially if they're expensive. The solution is to perform the computation and store the result in the appropriate document and collection. If you need to redo the computation or want to be able to redo them, just keep the source of your computations, meaning keep the smaller documents or piece of information. Common use cases where you may want to use the pattern are the Internet of Things, event sourcing, time series data, and any scenario where you do repeated similar aggregation queries. The benefits you get from the computed pattern are faster read and less utilization of resources, mostly CPU and disk. However, it may be difficult to diagnose that you may benefit from such patterns on a large existing cluster. It is easy to abuse the computed pattern. Use it when you need it, as the required computation may add complexity to the application code. So here it is, this is our computed pattern. In summary, the computed pattern is a useful pattern if you want to avoid performing similar operations many times.